Good evening, everyone, and welcome to SocialFlight Live. I'm Jeff Simon. We have a fantastic show for you tonight. I'm so excited. Elliot Seguin is here. We're going to talk about test flights, so many cool things going on. Before we get started, as always, just a few housekeeping notes. There will be a recording available of tonight's broadcast. It can be found on socialflight.com and the SocialFlight mobile apps, as well as on SocialFlight's YouTube channel. Just search for SocialFlight, one word, you'll be all set there. Also, as always, we want to remind you that we created SocialFlight in order to support General Aviation and to support you. That's the whole point of it. With all of our giveaways, with everything else that we do, we're here to help General Aviation. And so with that, we'd like to ask, it's completely free. Be sure to check out the website at socialflight.com, sign up, and also check out the mobile app because it has tens of thousands of events. It shows shows like this, tons of education, videos, and so many great destinations. We really believe that it is so important to be able to get out there and fly even during the crisis. And that's why we created the SocialFlight Live show, because of course so many of us are stuck at home, and it's really helpful to be able to see these inspiring stories of people that make General Aviation what it is and encourage you to get out there and do flying with safe social distancing as much as you possibly can. We are a fragile community in General Aviation, and the ability to get out and support your local FBO, your local airport restaurant, to keep your aircraft airworthy and up to speed. And also, I can't think of a better time to invest in your aircraft than now. You may actually, through that, be not only supporting yourself, but helping save someone's job at a company. And so please do that, support everything that you can for General Aviation. With that, I would like to begin our show tonight and talk about Elliot Seguin, who is from Wasabi Flight Test. Now, Elliot is just the best way to describe him is he is all about design, build, and test experimental aircraft. And since 2005, Elliot's been working in the field of research and design of experimental aerospace products. He spent 10 years at Burt Rutan Scaled Composites as a project engineer, flight test engineer, and test pilot with 300 hours in 6 types of Rutan experimental aircraft during his tenure. He spent 2 years as lead test pilot at Mooney Aircraft, working on the prototype carbon fiber diesel M10T, and has set 6 world records and built 2 airplanes for racing at Reno, and one of them of his own design. It is hard to imagine a more fascinating day at the office than the ones that Elliot sees on a regular basis. Welcome, Elliot, to the show.
Thanks for having me.
You know, we have to start at the beginning here because you have one of the most fascinating jobs in aviation. And you got there at a relatively young age, considering. Tell me a little bit about your background. How did you evolve to the point that you became who you are today, and maybe how'd you land yourself at Rutan Scaled Composites?
Sure. Well, first off, yeah, thanks for having me, and I appreciate being here. You're talking a lot about general aviation during your intro, and it's certainly something that I'm passionate about. You talk about how I ended up in Mojave and doing the silly stuff that we do. It all starts there, right? So I grew up in a flying family. My old man had a Swift, and we used to fly it around the airport. And I was pretty sure that there wasn't much difference between a Swift and a Mustang or Sea Fury or anything like that. It was pretty much the coolest airplane on the planet. Anyway, so it sunk the hook nice and early, and started a path towards Mojave and towards all that. So yeah, from there it was engineering school, and then out to Mojave. So.
What type of engineering did you study?
Mechanical engineering. So most of my time in high school was spent really focused on horsepower production. I worked for a guy building. So he made his money building Fords, the old flathead Fords, but he also played with Stearmans and T6s. So he was building 1340s and Continental 220s, and that was the whole reason I was there. So I would spend all day doing the car stuff in exchange for getting to do the radial engine stuff in the evenings. The joke was, I was telling my dad how cool of a job I had. I get to work with radial engines all day, and he's like, "You're going to engineering school. It's expensive, but you're excited to be working on these old antiques. Elliot, no one's going to pay you to be an engineer on radial engines." And there's some some truth to that. But anyway,
I feel like I got to drag my son Jake over here. He's going through exactly the same thing in terms of like A&P school, just got into UMass engineering, whole thing, and he wants to basically be you, I think. But we'll figure that out.
well, and to be honest, I think I'm not saying I'm the best engineer, but the best engineers, I think, there's that practical side to it. And if you're going through engineering school, the awkward thing is you're learning theory, right? And that difference between the theory and the practical side, right? I mean, if you're interested in the theory itself, then you're going to go study physics or a math major or whatever. Like engineering is about the practical application of those theories. And so that combination of living between the hardware and the theory is like key to the engineering dilemma. And I wouldn't be surprised if a lot of good engineers struggle with it. Not that I'm a particularly good engineer, but I think a lot of engineers struggle with it.
So what was the connection then that then landed you after, I assume it's after your mechanical engineering degree, to actually start really wrenching on airplanes and putting your engineering to use?
Yeah, so that moment I talked about with my old man ended up, we'll say it was one conversation. It may have been more than one, but we were just talking a lot about, how do I apply the engineering education to what I was passionate about, which I'll joke and say it was round motors and tail draggers, but the Reno thing, right? And not maybe specifically Reno, but the idea of modifying aircraft for very specific purposes. I couldn't have put it that clearly back then. So I put together a list of the coolest companies I could think of, and sent them all letters telling them how cool I thought they were and how I wanted to come help them out. And you're writing the addresses on the envelopes, and you're like, oh, Mojave. And it turned out that most of the companies I was interested in working for were all in Mojave. So I got in my cruddy old pickup truck, drove across the country, and started banging on doors trying to figure out how to pay for food while I found a real job. And that's how the whole thing started. So
you really did it by driving out there and putting yourself there, as opposed to mailing in all the opportunities.
Yeah, it's I think maybe compared to other engineers, I probably am better face to face than some engineers, but more so, Mojave was in this explosive time, right? I graduated college in 2006. Spaceship One was what, 2004, right? Global Flyer was going around the world while I was trying to get these jobs. Like, there was probably not too many more competitive places on the planet to try to get an engineering job than Mojave. Scaled in particular, but really the whole airport, right? The whole, a rising tide raises all boats. The whole airport was sort of buzzing, sort of like if you were trying to get into SpaceX or something like that now, or some of those guys in the Bay Area. So it was real competitive, and the way I set myself apart was with the flying background, the practical stuff, building round motors, and then being willing to put myself physically there. So, well, and also just harassing the guys till they would talk to me.
So what was your which came first? Was it first doing some of the things on your own with aviation, or was that your first job getting into Scaled?
So no, my first job was not getting into Scaled. Scaled wouldn't talk to me. So I started looking, I joke about looking for jobs like it was the end of college. It was actually the year before the end of college. So I had one summer to go and 1 year of school to go. And I was trying to set the footprints in that path to figure out how to be full-time at Scaled. And Scaled wasn't taking interns. And anyway, so I ended up working for two companies on the airport as an intern. One was Nemesis Air Racing, working on the NXT, carbon fiber race plane that was the hottest thing on the planet, and XCOR rocket engines, or XCOR Aerospace. They had just done their rocket powered long easy at Oshkosh, and so those were the two internships, and it worked out really nice. I'll say that I planned it, but I'm not that smart. But they were on opposite sides of Scaled on the Mojave flight line, and my Nemesis internship came with a flight line badge. So instead of I would park my car at Nemesis in the mornings. XCOR would get started kind of late, and then to go to XCOR, I would walk, instead of on the parking lot side, I'd walk down the flight line side, which meant I got to look in all the Scaled hangars. And I kept, this is so nerdy, I shouldn't be telling the story, but I kept a journal like this size, but a little smaller, of, okay, on the, August 22nd, I met a tall man with blonde hair. His name's Burt. He appears to be sort of a big deal. I need to Google him later. And then, I saw,
You're like the best kind of aviation stalker there is.
Right, and the trick is to not be sketchy while you do it, which I'm not sure I ended on the right side of that coin every time. But it was at the end of the day, I mean, those are jokes, but it was hard to get into Mojave, get into Scaled, and it's a big deal. Anytime you graduate from college, you just have to go out and get a real job. And I'd only been a mechanic professionally before that, working on the round motor. So it was a big step, and I cannot believe how fortunate I was that the moment was happening and that I was able to be a part of it, the thing that was happening in Mojave.
So let's show this. We've got some pictures here during tonight's show that we can bring up here. There's a little enthusiasm here on this XCOR one, right?
Yeah. So I was sort of making jokes earlier about my personality relative to most engineers. And I think this sums it up. Those XCOR guys, such an impressive group, but very much led by a technical mind. I think a lot of engineering firms are that way, but XCOR very much so. So that's Dan DeLong sitting in the rocket racer. We're doing engine runs. They would do them right out in front of the hangar, which could only happen at Mojave. The gentleman on the canard, his name was James. I don't know his last name. He was a local long easy expert who was in charge of doing the airframe side of the rocket racer installation. Anyway, so I was super stoked to be there, and it got to be sort of a running joke that Elliot wanted to have his picture taken with stuff and wanted to whatever. So that's the moment there where I'm like, can you guys take my picture? And they're like, yeah, with bunny ears. Pretty well sums up my experience in a lot of my life.
Just to make sure for everybody knows, XCOR is the rocket racing that was going on there, right?
Right. So that airplane that I'm pictured with there, a long easy with a rocket motor in the back of it, demonstrated at Oshkosh, which I'm sure you guys remember. I remember it. It was a big deal when I saw it, with Dick Rutan flying the airplane, which was super cool. That got enough eyeballs that started what was eventually called rocket racing. When I was at XCOR, I was there actually for the beginning moments of that. So I was with XCOR when we went at Oshkosh to the Velocity booth and pitched to Velocity to buy Velocity airframes and put rocket motors in them. Where that ended up going was two rocket racers were built. XCOR built one. I wasn't a part of the program. And then Armadillo built another one down in Texas. They both flew many times. I don't think a race was ever demonstrated, but there was the program had some legs, and this is the genesis of it here. This long easy with the rocket motor in the back.
So if you want an example of the things that we lose out and the world misses out on when you don't have an Oshkosh, it's things like a bunch of guys saying, what's the coolest airframe? Well, it's a long easy. Well, what can we do to make it cooler? Let's put a rocket engine on it.
Right, and so this, we're talking about how cool XCOR is, and I think that's the most important thing about the XCOR deal is, so they're egghead rocket guys. Rocket guys tend to be eggheads, engineers eggheads, so it's like double egghead. But the most important thing was they recognized that there were a lot of rocket engines out there, rocket engine companies out there, and what would set them apart was flying. Dan had this long easy. He had it in the back of his hangar, and they had a rocket motor that was near the right thrust, and they put them two together, and now they were the only rocket engine powered airplane flying currently in the United States. The joke is, and I hope I'm getting this right, apologize to the XCOR people that might be listening if I got it wrong, but the joke is that in the build up to Spaceship One, nobody knew Spaceship One was happening. That was across the ramp at Scaled, XCOR's down the ramp. This thing was flying. Dick was doing most of the flying. Dick Rutan, Burt's brother, is very close with Mike Melville. They're close buddies. Dick talked the XCOR guys into letting Mike fly the rocket-powered Long Easy. And the joke was that they didn't realize that they were in fact training their competition, right? XCOR and Scaled XCOR saw themselves in competition with Scaled, and by putting Mike in there, that was actually his first rocket-powered airplane flight before he went and flew the spaceship. Like, where else in Mojave could a test pilot wander down the ramp to another rocket-powered airplane project, right? Like, super cool.
Hey, you guys got another, we need a part for a rocket engine. Oh, sure, it's right over there. Yeah. No problem. There's tons of rocket engines around.
It's a Rocket Zone, AutoZone joke. It wasn't funny. Pick up some rocket engine parts. To that point, though, there's a Ace Hardware in Mojave. It's the best Ace Hardware I've ever been to in my life. And it's because all the aerospace companies, so they can afford to stock up on all these weird items. I was just, we were talking yesterday when we were setting up for this thing about flying that turbine-powered Thunder Mustang down in Florida. And we had a part break on it, and it was just a little Heim joint. It was like a number 10 Heim joint, something like that. I was like, I'll just run down to Ace Hardware and pick it up. And it totally... Because in Mojave, you just go down to Ace Hardware and they have, female Heim joints, male Heim joints. They got the ones with off sizes. They got the ones that are the way they're supposed to be, the same. Like, Oh wait, nobody has. I think I went to O'Reilly Auto Parts, Lowe's, Home Depot. There was like a bolt shop. Anyway, and the Ace Hardware, and nobody had Heim
The
joints.
only Ace
in,
Hardware
DeWitt,
with
Florida.
mil-spec parts.
Yeah, right. Only in Mojave. Right. It's a special place.
Oh my God. Well, here's another one. You said the other half of what you were doing there was Nemesis.
Right. Boy, is there a better looking airplane out there. Yeah, so that's the Nemesis NXT. So the context of the photo, that's after setting the 3-kilometer record at Oshkosh, which was, you want to talk about moments in my life that set the hook. You know, you grow up reading about Lyle Shelton and Daryl Greenemeyer and, 3-kilometer record and what's a 3-kilometer record, and, tie that back to Doolittle and like all the badass stuff. And to be able to be a part of a team setting a 3-kilometer record, I mean, it was absolutely spectacular. Because John is John, he said it at Oshkosh in front of a crowd, which is incredibly, it takes a lot of gall to attempt that, and he was successful to set the record at Oshkosh. And this is the photo we took as we towed the airplane through Aeroshell Square, just at the gate to Aeroshell Square before we put the airplane away for the night after setting the record. So
Wow.
That's pretty rad. So other things about that photo, this photo as well, the pink cowling was put on after the gear incident. So if you go watch Christopher Webb's documentary, have you seen Christopher Webb's documentary?
No, I got to watch that one.
It is phenomenal. So Chris Webb, he's a guy out in New York, and he's a great filmmaker, and he was following Jack Cox. You're familiar with Jack Cox?
Oh yeah, of course.
Yeah, so Jack Cox, he went to Jack Cox and said, I want to make a movie about airplanes. Is there any cool airplane projects that are going on right now? And Jack said, you got to go check out these guys in Mojave. So he got involved with Nemesis from before the first flight and was there for the beginning or the final construction through first flight. And then the documentary goes through the gear collapse at Reno, and then finally through winning at Reno. The documentary is called Air Racer, Chasing the Dream, I believe is what he called it.
Wow.
If you watch the documentary, there was a hydraulic failure on the airplane, the gear folded. And we talk about moments where Elliot was luckier than he deserves. One of them was getting into scaled while the Spaceship Two program was still gearing up. The other one was approaching the Sharps, the Nemesis team, right after the gear collapse. So there was, they are a world-class race team, the best on the planet. And at that moment, when the gear collapsed, I would say they were more accessible than they've ever been. And that just happened to be, just a couple months before I reached out to him. And I didn't know that. I was just some bum in upstate New York. Anyway, so that made them give me more time than they probably should have. And I ended up being there while we did that paint job. So that paint job with the new, there's some changes they did to the cowling and to the whole front of the airplane that I got to be there for. And to be there for sort of a pivotal moment as you watch an airplane that's going to go do a very focused thing, something that I've ended up dedicating my life to be there for the pieces coming together and making this stuff happen was so fortunate. And a big thing about EAA, a big thing about Mojave, and a big thing about Nemesis. Am I rambling yet? Is this
no? This is what this show is, by the way. So buckle your seatbelt. This is exactly what we're. So all right. So you've got Nemesis now under your belt, spending time there. You've got XCOR. You've already strapped rockets, long EZs, and was that the combination that took you to the next step then?
So after that summer, I had my notebook. Every time a Draken took off from the test pilot school and there was a Zero flew while I was there, it was like abandoned on the airport. Anyway, I had my little notebook and the hook was sunk. But a big thing, I mentioned I went to mechanical engineering school because I was interested in horsepower generation. Being there and seeing the experimental thing made me realize like the airframe side might be more interesting than the engine side. So that was when I sort of made the decision that like I had been interested in scale, but I needed to really focus on scale. So when I left after the end of that summer, I spent the whole following year just focused on getting Scaled's attention. And it was a really scary time from having all your eggs in one basket situation. I was talking to other companies, but nowhere near as aggressively as I was talking to Scale. To that point, I had a list of engineers at Scale that I would call every Monday morning. And the best part about that is I didn't find out till later that they sat all in the same room. So one would answer, and then the next one would answer.
And go like, it's Elliot. Hold on. Yeah.
Yeah.
Who do you want to talk to next?
Exactly. Anyway, so I did that for the better part of a year until I got the offer letter the day that I graduated, and I drove back out to Mojave and started my career at scale. So yeah, anyway, that's that.
So they hired you so that you would stop calling them.
That's right.
And then they got to see what your skills were.
They were short on floor sweepers. Sorry, so we just put a guy up in a Seafury that's never flown in a Seafury before. They just landed and they're just coming in. So if I'm distracted, I apologize. But yes, they were short on floor sweepers, so they let me help out with that. Thank you. Anyway,
let's show, because this is no small feat of some of the things that you did there. We got a few pictures that may be in or out of order.
So I think of all the projects I got to work on there, the White Knight stuff is the stuff I'm most proud of. So that's one of the only a handful of times in the history of that airplane that it flew with 3 people on board. So the 3 of us in pickle suits all flew that day. Ended up being 2 successive presidents of the company on my left shoulder there. One was flying the airplane, the other was sitting next to me in the back. Behind us is a payload that you can't really see, and it's a good thing because I can't talk a whole lot about it. But White Knight is just a really special airplane, right? I mean, it's designed for a very specific topic. How's the sound? Are we getting a lot of side?
You're good. You're good.
Okay. I mean, it's a really weird airplane, right? So it was designed specifically to carry the spaceship. So you see that whole geometry is set up. I mean, you can see the ladder behind me. It takes a ladder, like a serious ladder, just to get in the cockpit. So like from a bailout standpoint, there's a rope ladder in the airplane in case you have to, if the engine's on fire, you come to a stop on the runway, so you can throw the rope ladder out and get down the airplane before the fire trucks get there. So anyway, it's a really weird airplane. It's weird because it was designed for a really specific purpose. I wasn't there for the Spaceship One stuff, but I was there when we figured out how to make money with the airplane. So we did several payloads for different types of customers, hanging stuff off the bottom, right? So fundamentally, that whole geometry is about being able to fit a spaceship underneath the fuselage. Well, when the spaceship goes away to the museum, there's still a big space there. We actually flew with a vertically mounted wing under the airplane, where you would put beta on the airplane in order to put alpha on the wing, and then we could study the wing almost like a flying wind tunnel. That's just one example of program. But the other side is, right, the airplane was designed, I mean, it's a big compromise. It was all designed to require as little engineering as possible. So everything on it is stolen from another airplane. So this is a great photo. Thanks for putting that up. If you recognize, the front of the airplane is the front of Spaceship One. Right. So why does it have 3 seats? It has 3 seats because Spaceship One, in order to win the X Prize, had to take 2 passengers to space. So there's 2 seats behind the pilot, right? And so then you're like, well, that seat, or that hole in the side of the airplane where you get in, is like awkwardly behind the pilot's seat. Well, that's because the initial plan was to use the nose for ingress egress. That ended up changing, but that whole nose is removable. So you see there's like a big seam there. It opens like a bank vault, and it turns like 5 or 10 degrees, and then the whole nose falls off. You're like, well, this is a big, slow flying. Well, it's not for the mothership, right? It's for the spaceship, right? So if in the event that the spaceship on going out of the atmosphere or coming back in the atmosphere was tumbling in any axis, right, you could effectively just make the front of the airplane disappear, and all you'd have to do is unbuckle your seatbelt, and you would be projected out the front of the airplane. Doesn't make sense for a mothership, but makes a lot of sense for the spaceship. Right. The joke I always made was that we'd do stuff in the airplane, and you're young, and you're trying to figure out how much risk you're taking on a given day. And the concern was that if something happened, right, if there was a fire or something terrible, that my front seater, because I was in the back, the front seater would just do that. He would just open the nose and bail out, right? And I would have to climb around his seat to awkwardly get out. I said, well, if I'm going to do that, I'm going to fly the airplane for a second. You just put my hand on the stick, right? I logged 0.1, damn it, on the way out the doors. Sorry.
Well, you have to get that somehow.
If you don't mind going back to that photo for just another second.
The
motors are afterburning J85s out of a T-38. Doesn't make sense to put afterburners or really low bypass turbojets on an airplane that flies at 150 knots, right? Well, they were like that because the rumor is that Burt found them on eBay, and the deal was so good he couldn't turn them down. And say, well, okay, but if you're going to plan on flying the airplane in burner all day, you're going to have like a serious fuel flow problem. Well, that's why the thing is a flying fuel tank. If you go back to the previous photo. So right above, see the first guy in red, right above his head, from there in the wing all the way to the wing tip is gas.
Oh God.
from the spar forward. And they Burt specifically put the spar further back in the wing so that there would be more fuel forward of the spar, just to deal with this problem that we got really cheap engines. So we're going to design the whole airplane to deal with those compromises. And that is.
Don't they say that like all aircraft are designed around the engine? So there you go. Like
there you go. So it's actually very common what happened. Anyway, if you look at that same photo, the gear, you can see the gear on the right side. The gear was pneumatic, extended via pneumatic actuators. The pneumatic actuators were the same pneumatic actuators that feathered the feather on the spaceship. So it was a way to get cycles on those systems before the spaceship existed.
Oh, that makes a lot of sense.
That inboard section of the wing between the boom and the fuselage there's a spoiler that runs the full trailing edge. It's maybe probably 18 inches in chord, and runs, well, there's two sets of them, but they basically run from the center boom to the outer boom. There's a lot of drag there, and there's a lot of drag there so that you could actually fly spaceship approaches in the mothership.
Oh, just to practice.
Just to practice, right? So to that topic, Melville took his long easy and he put decals on the inside of the canopy. Thank you, Jamie. Put decals on the inside of the canopy with the same porthole design to try to practice flying out of the spaceship before the spaceship exists, right? Because flying out of portholes, like, what's the risk there? I don't know, and it's a very scaled solution to just put decals on my long easy. It's even more a scaled solution to say, let's just make the mothership a lot like the spaceship, and then we'll set up the mothership so we can fly the approaches, right? I mean, it's very Burt, it's very cool, and I'll quit rambling about White Knight, but it's a
no way.
Cool
That's fascinating info. I never knew that, and it's amazing, and it makes so much sense. Everything except for maybe the eBay part, but everything else, right, that led after it, like reusing everything that you can on that's fascinating.
It's such a cool airplane, and to be able to, build it for one customer and be able to find work for it with other customers it was cool to be a part of it.
Well, that, as you mentioned earlier, just about I guess the vast majority of the work that you do is on very, very purpose-built aircraft.
Right. And somebody was talking about Burt's genius, and that everybody talks about Burt's ability to solve interesting design problems with cool configurations, et cetera. And the joke we always had at Scale was what Burt was really good at was finding a mission that allowed him to come up with a really weird configuration.
That makes sense too. So now we have the next one from Scaled.
Yeah. So that's Proteus flying a monster pod that we flew for a long time at Proteus. This was the first time I flew for Scale, the first time I ever flew for work, actually. That program, we were running up to the 50,000 foot range, and we were pretending to be a Global Hawk. So that pod was destined for the Global Hawk, and it was cheaper to run a Proteus than to run a Global Hawk. So we would go up and fly racetracks in the restricted areas over Edwards, and they would pretend we were a Global Hawk, and they'd move stuff around on the ground, and we'd point stuff at it. Anyway, but it's a great example of what the airplane was designed for. Proteus was designed as a high altitude relay communications relay point. So it was designed to hang out for 10, 15 hours up at super high altitude. So this was very similar to that. Your first flying job is at above 50,000 feet, flying for 8-hour, 9-hour sorties. Only in Proteus is that possible. Anyway,
wow. That's fascinating. So now tell me a little bit, how did you move from project engineer, flight test engineer, and then all the way up to test pilot? And of course, that's where the focus of most of your time is now. And obviously, you've got a really strong grasp from your background on the work that they are doing as a test, on the things you're testing, the understanding of the science behind it and what they're actually trying to do. So what was it like going through that progression?
Yeah, I think there's two parts to that question. One is sort of what is the typical path to the test pilot role, and the other is how does Elliot get the hook sunk to overly focus on such a narrow career path. So we'll start with my narrow career path. I think just like we were talking about earlier, that blend between practical and theoretical, right? The cool thing about flight test is it draws you even more so to the center of the Venn diagrams, right? To what really matters, right? So we talk about design, build, test, or it's really design, build, test, operate. And if your operate doesn't work, then your design was terrible. And so in order to understand how to design, you have to understand the other phases. And that was something I hadn't really been exposed to until working at scale. You know, working as a mechanic, you're sort of stuck in that last phase where you just hate the engineer for giving you a cruddy thing that's hard to work on. It's not till you've been through the cycle that you understand, you know, how the fog of war makes it hard to see the problems that are actually going to be a problem when you come down the line. And so that was the most rewarding thing about being at Scaled, was going through that process quickly. You know, there was a time back in, you know, we were just talking about the Sea Fury out in the hangar. Sidney Cam designed the Hawker Sea Fury. He designed, what, 30, 40 airplanes in his career. Kelly, right around the same number. And there aren't people that design at that rate besides Burt in the last 20, 30 years. And so that's the most special thing about Scale, is that there's been so many airplanes that have happened on the same patch of ground. And what that means is that there's a lot of lessons learned that, you know, we joke about them hanging in the eaves, but otherwise you would have to travel all around between companies to be able to get that, to go through that cycle: design, build, test, design, build, test, design, build, test, which is where you learn, right? It's not until you see it fail that you understand how you could have designed it better. And being there and watching that process was a game changer for me, and helped me understand that that was what I wanted to dedicate my life to. The other thing that was interesting about Scaled is it was test pilot focused. I don't want to make assumptions about Burt, but, you know, Burt and his brother were, I think, competitive. You know, they're both two young guys interested in aviation. Dick went off and joined the Air Force and was a badass fighter pilot, and Burt was the egghead engineer who went to, you know, ended up at Edwards as a flight test engineer. And I think in some ways, besides Burt's desire to just build lots and lots and lots and lots of airplanes, there was always a want to be a test pilot thing in there. And I think in the early years of Scale, that's why he took such an active role in flight test. But what that meant is, as an organization, the organization put test pilots very high in the structure. A lot of companies put the test pilot in a quality control side, right? So it's separate from engineering, and they're almost like a nuisance, right? Because their job is to figure out if your design works, and therefore they're kind of in the way. At Scale, the test pilots were, I mean, and it goes back to Melville being best friends with Burt. I mean, they were best friends, and Mike did the majority of the high risk flying for Scale. And so that dynamic meant that not only was flight test probably interesting to me personally, but it was also the top of the tree that I happened to be living on, if that makes any sense, which makes it easier to sort of drive your career that way. So once you make the decision that you want to be a test pilot, there's the question is, how do you get there, right? And I think that's maybe the other part of the question that we're asking. If you were to go to a test pilot school and ask them that question, they would say there's basically two paths. One is you go join the military, you become a fighter pilot, you get your 1,000 hours, 2,000 hours in Vipers, and then you convince them to send you to test pilot school. So it costs about $2 million to make a fighter pilot. Let's assume while he's, you know, doing his 2,000 hours of flying for work, that's recovering the cost, but then there's another $1 million or $2 million to go to test pilot school. So it's like $4 million the government's investing in you to make you into a military test pilot. I'm not saying that it's not worth it. I don't mean to comment on the budget. I just mean to comment on the other side, which is when you're trying to compete with those guys on the Civvy side, which is where I end up. The Civvy path is to typically you join a team as an engineer, and then you work your way from the sort of a design role into sort of observing the test of the thing that you design in a flight test engineer role. And then typically on a time scale of 7 to 10 years, you make the slide over from right seat to left seat or back seat to front seat, however you want to think about it. And in my experience, those testers are the most valuable. The problem is that because the scaled operation is so unique, most of the guys that come up that way are on a very narrow range of products, right? So if you came up at Cessna, you probably came up in either the single engine wing or the multi-engine wing, or you came up in the jets. You're going to be there. You're going to be in single motor Cessnas, and you're going to be awesome, right? But if you were to step out of that and you were to go look for a job, besides going over to across the street to Piper, right? Your skills aren't really applicable.
Right.
And so that's the risk of the engineer career path. In some ways that put me at an advantage. In some ways it put me at a disadvantage, because our situation was that just as there was a handful of us, right? So am I rambling yet?
No.
Okay.
No,
I apologize.
but you know what you're saying makes a lot of sense, because I mean I've worked at some of those companies. I've worked with the flight test engineers and through that and the flight test pilots, and I do agree. I think it's a shame when some companies really view their flight test department as almost like quality control at the very end. Like,
Right.
just, you know, we know it's going to do all this. We just want you to report back on this. They're not
Tell
really
me that it's
involved.
doing the thing I told you it was going to do. Yeah.
Yes, exactly. As opposed to like having them really understand it and give you feedback on the genesis of the product you're making, and understand that. So that makes a lot of sense. Tell me one thing. I've always wondered, you know, the Rutan designs, for example, and the scale designs, they're so artistically unique. They're so targeted in what they actually do. It almost makes one wonder how much of a focus there really is on the flyability of it or of the pilot experience of it. Tell me about that.
The joke is that the scaled airplanes all handle terribly. If you've flown a long easy, you might have had that experience personally. Not saying a long easy flies terribly, just that if you were to compare it to classical handling qualities, it's not spectacular. Yeah, so I think there's a lot of ways to answer that question. So I'll just ramble for a while, and you like put your hand up when you want me to stop. One of my favorite things about Burt, and especially after getting to know him, is number one, the salesmanship, which I think, you know, you talk about Kelly Johnson, there's a salesman, or Beatty, right? These are sales guys, and it takes a lot of bucks to be Buck Rogers, and it takes a lot of dollars to move a program like he moved them. And so I don't know that gets talked about very much. But the other one is like his intense drive and his intense, you know, I used the word egghead earlier, so we'll keep that on trend. I mean, he's a technical, engineer-minded person. And so one of my favorite things about being at Scaled was seeing the early napkin sketches when the configuration's being initially hashed out, where it's, I know I want a canard, I know I want a pusher, I know I want, you know, tip sails, but the art wasn't added yet, right?
Yeah.
And I think for me, that credit always went to a man named Corey Bird, who is currently the president of Scaled. Who you know, came in with a broom sweeping the floors. And if anybody knows Corey, I'm not doing him justice, so I'll apologize. But I will summarize by saying the pivotal moment that I see in Corey's path from guy coming in sweeping the floors to president of Scaled, engineering design badass, is in the middle. He designed and built an airplane called Symmetry, and if you Google it, you'll recognize it. It's a little yellow airplane with a T-tail on it. And if you look at it, the design, you know, it's a little airplane, great, but the aesthetics are outstanding, right? And that process of going from, you know, a non-degreed guy who's interested in designing airplanes to Burt's key designer, a lot of that comes, designing and building your airplane is a way to do that. And I think the timeline doesn't quite line up, but I always thought of that as being a critical moment for Corey. In improving himself within that organization, and adding the pretty to the designs that if Burt had control of it, they'd be pretty rough, because Burt is so focused on, you know, getting it out quick and cost, and, you know, what's the minimum that we need. Does that make sense?
Yeah, it does. I mean, you know, again, anytime you see these, you've flown some crazy planes, and even when you see some of these other Burt Rutan designs, the ones that have always caught my eye, Boomerang, Grizzly, hanging out at, you know, parked on the side over there at Oshkosh, you see these and you can't help but ask yourself, what did they fly like? You know, why aren't there dozens of these or hundreds of these in the sky, or like what? Because they're so crazy. And so you're someone, maybe not on those two designs, but on so many of these, you get to see what these things fly like when someone draws something that's pretty wacky.
And I think that was one of the most important compromises that Burt was able to make, but most airplane designers aren't able to make, which is to say we can just throw anything to do with the pilot away, because my best friend Mike Melville is going to be flying it, and he's a bad man pajama, so I'm not worried about it, right? So like Proteus was super light in pitch and obnoxiously heavy in roll, right? So we've spent most of the time flying that thing on autopilot, just from a handling standpoint. White Knight 2, similarly, when it's slow, is really heavy and roll, to the point where the guys will actually reach across. They have a stoke in front of them, which is functions like a stick but has two handles on it like a yoke, and they'll actually reach across and grab the other stoke to turn, because the stick forces are so high, slow in the pattern, right, where you're doing all that maneuvering. So, and again, I think that speaks to Burt's genius, right? Most of his airplanes were never going to be flown by a consumer. They were never going to be, so a lot of his stuff is sort of flying wind tunnel models or flying desk models of a concept. And so if you're looking for stuff to get rid of that's expensive, handling qualities can be expensive. So it can, like fuel management, right? Proteus has 15 fuel tanks, if I remember correctly. and you're manually moving fuel between them on an 8-hour flight. Does that make sense anywhere except for where you have a tremendous relationship and respect and willingness to give responsibility to your test pilots? No, and that's why
you're not designing
that's
for
why
the
it's
masses.
such a right.
I want to make sure we get a couple other pictures up here, just because for the record, and also because it looks like you're 12 years old. But
yeah, that's a particularly young-looking Elliot. Sorry about that.
Where's this picture from?
So that's flying with Mike Melville in Proteus. Trying to think of good stuff to talk about. So
Then,
if you notice, go ahead.
You can go back to that one. Yep.
So first of all, you notice that there's space behind the seats. Behind Mike, there's like it looks like a cupboard, and it has some computer stuff in it. The reason why the pressure bulkhead is not up against the back of the seats is because the idea was, because you're flying for 15 hours, that you could find young, brand newly issued commercial pilots that would be willing to fly this thing in order to just build time. And so you'd put 2 guys in it, and they would alternate flying responsibilities, and the other guy would sleep. So they moved the pressure bulkhead back so the guy could lay down and sleep. And that's why there was all that space behind the seat. There was 2 occasions in the 200 hours of flying Proteus that I have where we had to go back there and mess with there's some computers back there we use for data logging, et cetera. There's a keyboard and a mouse. And 2 occasions I had to go back there. And so the idea of, well, there's a slight space between Mike and I there, right? So you have to fit through that space. So if you're going to keep a parachute on your back, it's going to be harder. So you probably want to leave the parachute in the seat. And you're probably going to end up disconnecting your headset. And then you're standing, the door is kind of almost on the bottom of the fuselage. So you're not standing on the door if you can help it, but you might accidentally stand on the door. And you're flying around in a carbon fiber, hand-built airplane at 50,000 feet that was designed to fly 100 hours, and you're now into hour 2,257. You're like, what am I doing with my life? Above Mike's head, you can see that insulation. That insulation is the only thing between you and the carbon fiber that's touching free stream air at 50,000 feet, cold. It's expensive. Well, I mean, it's expensive compared to some things. So there's not any on the right side of the fuselage. When we first started flying, later we put it in on the right side of the fuselage. So one of the big things you had to do before you took off, usually the night before, was try to get a feel for which pilot you were flying with and whether he was going to wear long johns. Because if he was going to wear long johns, then you needed to wear like 2 pairs of long johns because you were going to be colder than him, whatever worked out. Now, the sections of the airplane where that insulation wasn't, actual frost would form. And you fly with Brian Binney, he was famous for bringing an ice cream sandwich. And he could bring an ice cream sandwich from home frozen, and it wouldn't melt before he got airborne. And he would set it on the floor of the airplane in one of the spots where the insulation wasn't, and it would stay frozen until, 4 or 5 hours in the flight when you feel like you need a little sweet treat, and it was ready to go.
Surprised you're not making ice cream up there at altitude.
Likewise, go ahead.
Yeah, I was just gonna say you had another one here also. That's a big proud shot of White Knight.
Yeah, I typically don't pluck this photo, and when I sent it to you yesterday, I realized that I was thinking of the story wrong. So that photo looks like I worked on Spaceship, and that's why I never wanted to show the photo, because I didn't want to claim that I was working on Spaceship. And what that moment is actually was because I was walking up and down the ramp like we talked about, trying to get connected at scale. I got recognized and people knew what I was trying to do. And one of the guys told me, he's like, hey, they're having an open house today at Scaled, and the Spaceship's going to be there. Just show up at such and such a time. And I did. And this is that day. And I got to walk in and put my hand on a Spaceship underneath the White Knight, the airplane that I eventually got to work on. And most importantly, we talk about this great moment, I got the photo, whatever. I had my notebook and I wrote down the name of everybody I met at that party so that I could come back as an employee instead of as a visitor. So.
Well, hey, there's nothing wrong with having a fan shot there. It makes you just like everybody else, without a doubt. Now,
it was a good day.
Fast forward from that, and you designed your own aircraft. I mean, you got into the racing, you did that, and this is the one you designed. Is that correct?
That's correct. So we sort of got lucky earlier talking about Corey Bird. That path of designing and building your own airplane to get more responsibility at work, doing the same kind of stuff at work, is exactly what we're looking at here. So I was crewing for John Sharp. John had come from the Formula class. I wanted to take over racing John's airplane. That was all I wanted in the world, and I needed to prove to him that I was a good race pilot. And I wanted to be a test pilot at scale, and that required, both of which required flying, bad little airplanes. So I went and bought a cassette project, got the plane flying, did the flight test on it, took it, raced it at Reno. And the thing that happens when you come back from Reno is your fangs are still hanging out. You're still foaming at the mouth because you're like, you were trying to catch the guy, you were 3 mile an hour short or whatever the story is. And I'm like, okay, how are we gonna go fast? And it was a real watershed moment for me to realize that I could take a cassette and we put a new cowling on it, but I could put, another new cowling on it, and I could figure out how to build a good motor, and I could build a wing for it. And each one of these mods would be a year, right? And when I was all done, I would have a brand new airplane that I had done all this flight testing on and learned all the things that the world thinks I need to know in order to be a test pilot, but I would never have actually checked the box. I realized if we just throttle back, we just take that cassette back from burner to idle and slide it over in the other side of the hangar and start from scratch on a brand new airplane. Even if a year from now or 3 years from now, I decide I don't care anything about formula anymore and the landscape has changed, there's a different place I want to go, I will have had that experience in the book. I will have designed, built, and flight tested an airplane from zero. And
wow.
It was a hard decision. My now wife, at the time girlfriend, is standing there next to the left wing in that photo, and she was there with me for the whole thing. She started working at Scaled. Yeah, there she is. That's Jennifer. She started working at Scaled about the time I decided to do this project, and she was right there with me. So we would, Scaled works a 10-hour a day, or anyway, so Scaled works 10-hour a day, and we go home and go to the hangar. We lived, half a block from the hangar so that we could walk to the hangar. I didn't have to have a car. I had a 1965 Ford Falcon that ran a lot of the time, and I didn't need it. I could walk, just like we were talking about walking down the ramp, I could walk everywhere. So if the car broke down, I didn't have to fix it. I could focus on building the airplane. So we would work, we averaged 40 hours a week at Scaled, and then 40 hours a week each in the hangar, making that thing happen.
Wow.
And we were doing that. We were able to get it done in 2 years, also with significant help from everybody in the airport. So we talked earlier about that photo of me sitting with Mike. There's a magic thing that happens when you go from being an outside observer in a place like Mojave to being in it. And that's when you realize that you can't just ask Mike again, what's it like to go to space, right? Like you can't, like that's not the question, right? There's like, that's the very, like it's not even a question. Like you want to know the rest of it. Tell me the rest of it. And so in a lot of ways, what this airplane ended up being was my multiple choice test to all the things that I wanted to know, right? You go home and you scratch your head and you hit your head against the wall and you yell, Jennifer and I yell at each other about what the right path forward is. And then you have a great question to come in tomorrow and ask somebody about, right? And these ask the experts. There was a design problem. I don't know that you pulled the photo, but if you have any of the photos of the mold when it was in black.
I don't think I have that one.
There was a moment where so basically the fuselage was the first thing we did. So I built a cockpit mock-up and figured out how much space I needed. And then I took the engine off my cassette and I hung it off the front of this cockpit mock-up. And then we just started piling foam on it to make a shape. The idea being I could CAD model an airplane at work. If I was ever going to hand form an airplane like Corey Burt built Symmetry, if I was ever going to have that experience, now was the time. Because I saw myself working as an engineer for the rest of my career. I figured I'd design lots of airplanes in CAD. This was my chance to run a standing block. I had been working on it. I mean, this thing haunted me. I worked on it. It took a year to get that plug right, that fuselage plug. When I was done, it weighed the better part of 1,000 pounds. Yeah, here you can see the line. So if you see that body line, it's the most distinguishing part of the airplane. There's a body line that comes from the bottom of the spinner and it goes around the top of the wing.
Yeah.
I had the plug sitting there. So that's a 700-pound pile of plaster and Bondo with my engine buried inside of it, suspended on sawhorses, 10 inches off of a sawhorse. So it's up at working height, right? The cockpit's kind of up here and you can kind of walk around it and you can grind on it and make it happen. And I was destroying my hangar, so I had a dust booth that I built out of visqueen that was 3 foot behind the airplane on all sides. There was enough room for me to work. And I brought Corey Burt, right? Scale Composites, best designer. And nobody had known that I was working on this. And I was a big deal. I was like, Corey, do you mind? Like, I need some help. And he came down to the hangar, and I had something else I was showing him that I had a question about. And Corey came in and he said, that body line doesn't work. And what I had done is that line that went from the bottom of the spinner, it just sort of disappeared right in front of the wing. And then there was a separate line that started at my shoulder and kind of went down. He said, you got to connect these lines. And the problem was I'd been standing 3 feet away from it, and I'm a moron, so I didn't know it. And I happened to have, like, I could just go to the best in the world and bring him down to my silly program. Like, who gets that opportunity? And that is such a critical part of it. Like, there's a big ego thing, like, I designed and built my own airplane, and I didn't use just off the shelf airfoils because I did winter. Like, you can make it into a big ego thing, and I never, the goal was, and whatever, I'm a jerk like everybody else, but the goal was not that. The goal was to have the experience, to figure out what were the stupid questions. I'm a mechanical engineer, I'm not an aero engineer, so there's a bunch of stuff that I just had never even seen. And like, besides just reading the book, falling asleep at night trying to remember to write, this forced me to go, why is that equation important? just like your son, with the A and P, right? It's the same thing. Like, why is the problem important? Okay, now let's go figure out that theory. Let's figure out, how an airfoil actually works. Let's figure out how stability works.
So how much of that was the artistic side? Because I mean, you're talking about the, like you said, you came out of mechanical engineering, not necessarily aero and structures at that time, or the aerodynamics side, although I'm sure you're really well versed in it to some degree. But how do you go from that and blend what is the carving in the shop of what just feels right and has the art of it to the structural side of that and the aerodynamics?
So,
did you take everything that you finished with and then run it through finite test, or run it in a tunnel? What did you do?
So everything was done doing the simplest of methods. Again, the assumption was that in an environment like scaled or an aerospace engineering job, the state of the art, the F-35 solution, I was going to have that opportunity. What I wasn't going to have was the opportunity to do just like basic, napkin, selecting the right airfoil based on CL max and drag bucket, or picking wing area based on aspect ratio, tail volume, all those things. Right? I wasn't going to have that chance to do that the simple way, the old school way, the home built way. And so that was what this was a chance to do all those things. The artistic side, the structural side. I was before I came to scale, I had never done anything with composites. I was doing carbon fiber design at work, and so I had to learn it for that. But this was like, we did a major mod on White Knight, which required a lot of composite design and structures work, and then making the parts, etc. And to be perfectly honest, I used a lot of what I got comfortable with on that program on this. But it's one thing to use the scaled shop with their vacuum pump and their heat blankets and their oven and their resin and their acetone and their and then to do it in your hangar, and you have to say, well, is this clean enough? Is this the right, that's the heat blanket they use, that, I got this vacuum pump, is that enough, right? And to work your way through it. Or, come in after, this happened 2 times, where you come in the next morning and the thing you had built to heat the airplane with, I shouldn't say what it was because it's embarrassing, had collapsed and the tool had burned all night. Like black spots, like scrapping. Like, I never spent so much money in my life. A roll of carbon fiber at the time where I was paying like $3,200 for a 100-yard roll of 282 weave. Like, and this is skin, core, inside skin, and then another skin, core, inside skin, because you got all the overlapping joints and everything. And then heat lamp falls. I just acknowledged it. Heat lamp falls on the airplane in the middle of the night, burns a hole through the part. Like, what are we gonna do now, right? So just like you would have in a real engineering situation, right? I would say, okay, well, how bad's the damage? Can we count on that structure? If we can't count on it, can we repair it? If we can repair it, what can we take the new structure to? And do we have to add more plies because we can't get the structure out of it because we can't post cure? Blah 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 blah. This is another opportunity. So I'm working 40 hours at work trying to figure out how to be a good engineer, and I'm working 40 hours in my hangar trying to figure out how to be a good engineer, and just trying to do as fast as I can to create a microwave to generate these skills.
Amazing.
With flight test on the horizon.
Amazing.
Am I rambling yet?
No, this is fantastic. And it also reminds me, there's a book that I love and both my boys love, is Speed with Efficiency. And
yes, absolutely. That's it. That's exactly it. You're right where I'm talking about. 1000%. Sorry, I stopped you. Please introduce it.
Oh, no. I just if anyone's out there, just a great book. I'm trying. God, it's killing me that I can't remember the author right off the top of my head.
Is it Kent Pacer? Is that right?
Yes, that's it. Kent Pacer, Pacer, and recommend
Mustang 2.
Yeah, actually, I think it was an RV3 or something that he took. Maybe it was a Mustang, but he just, again, same thing, refine, experiment. And God, I mean, what was it, like
And to
60?
that point, if you read that book, there is no question that guy is as big of a stud out there as there is. But when he taxis up to the pumps, the data plate on the side of the airplane says Mustang 2, and that was the whole deal, right? That was
Exactly. It's still the exact same plane, even though he is light years ahead of
right,
anything. Put something like 60 miles an hour on an air, on
right.
it, like
Or like,
crazy things.
have you seen Dave Anders' RV4?
I have not, but I'm going to now.
Oh, same thing, right? Like, so you walk up the airplane, and you're like, oh, it's an RV4. Well, it's like, and I'm trying to remember it. I haven't thought about this, in a day or two, but I think he's like cruising 60 mile an hour faster than any other RV4 on the planet, right? Like every detail, he's figured it out. And it's not just like, there's a lot in aerospace, and I don't need to tell you or your listeners, but there's a lot in aerospace where you're like, well, I did a mod, so it must be faster. Well, how fast is it? Well, the increments between the two lines on my airspeed indicator are 15 mile an hour apart. So I think it's about 15 mile an hour faster, right? That is very common in aerospace. But in a situation like Speed with Efficiency or Dave Anders, right? They're going out and they're making the mistake, and then they're coming back in and they're working that cycle, the design, build, test loop, right? Which is what I fell in love with at Scaled. And the only difference between what was happening at Scaled and what's happening in Anders' shop or with Ken Pazer is just the scale of it. Scaled. Wow, that's terrible. The scale of the problem, right? I mean, there's a little bit of a difference between Spaceship One and an RV4, but other than that, it's the same deal, and it's why home building's cool and little airplanes are cool and all that.
So tell me how the story ended on this plane. This kind of like first love of your life that created all this stuff.
Yeah, created all that stuff is exactly the most important part of it. So we created that. We did the airplane. I think we did a reasonable job telling the story of building the airplane and releasing it. One of the things I'm most proud of that we did with it is we changed the conversation. So the problem with a racer or a record-setting airplane is you've defined yourself by the mission. So if you are not the fastest racer, if you have not set all the records, then you have no value in the community. The first thing that we did was change the script. So we flew at Reno. We did that. As an engineer, I was focused on presenting myself as a conservative test pilot rather than all, no holds barred, we're going to win this thing. And so you get done with it, people are like, what is this guy doing? I don't understand, because they're expecting you to be a racer. So what did we do? We came out of that and we flew the airplane nonstop from Mojave to Oshkosh. This is an airplane that's designed to do 8 laps on a 3-mile course, and we flew it for 11 hours nonstop from Mojave to Oshkosh. Again, we changed the conversation, right? And again, it allowed me to have a new design problem with the airplane. We had to put oxygen in it. I had to put an electrical system in it. It's a total loss electrical system in the racer. So I put an alternator on it so I'd have electrical power to get all the way out there. I put a relief tube in it. And then we had to find space for 50 some gallons of gas that was going to require to take it there. Anyway, it was a great little thing to do that allowed us to have a goal and then some modification, learn some stuff and go get it. What that ends up happening is we start to get some inertia. And the dream, it's the whole dream, right, is flight test. At this point, it was all I could think about. We started picking up flight test gigs, so paid gigs. And I had the opportunity to fly Dale Greenemeyer's Lancer Legacy and be a part of that program. With that, we set time to climb and 3-kilometer records. We went back earlier. We were talking about John Sharp setting 3-kilometer record. This is the coolest thing on the planet. And I got to do it twice. I set it in 2 different weight categories. That was the biggest distraction from my silly little formula that there could be on the planet. Okay, so you're showing the siren right now, yeah. So that's race 44. That was one of 2 sister ships, Dale Greenemeyer's race 33 and Lynn Farnsworth's race 44, that I got to work on for a while with a team called that did a bunch of engine work and airframe modifications to those airplanes, and that culminated with setting 3-kilometer records and time to climb records to 3,000 meters, or roughly 10,000 feet, and was literally some of the most rewarding stuff I've done in aviation. So backing up, right, we were talking about the kid. He's back in Michigan and he's reading about Lyle Shelton and Daryl Greenemeyer, right? And we're just reading about, it's after the races and they had an engine problem in the goal race, and he had just enough time to squeak off a test flight over Reno, and he went up and tested the ADI and everything was running good, but then the engine failed. I'm in a situation where the coolest airplane on the planet, at this point, John had retired from racing, so the NXT wasn't racing. The sport class was being dominated by the Lancers. And in my opinion, the most impressive team out there was asking me. I'd be in my little formula pit, and they'd start coming by at like 4 o'clock because the airport opens up, I think 5 or 6, something like that. Hey Elliot, we put a new fuel pump in, and we changes the settings on the fuel regulator. Do you mind swinging by and just squeak a flight off real quick? And I'm like, wrenching. I'm like, I don't know. I'll see if I can get to it. And like, meanwhile, like it's just the coolest thing that's ever happened in my life. Like as soon as they're out of shot, like I've got my checklist out. I've got my, I'm getting my head right in the game to go fly this thing. So what ended up happening being that was a real distraction from Wasabi, from the siren, and then we just ended up getting more and more flight test work that pulled us away from it. So now we're in a situation where I got 2 kids and a mortgage, and the idea of dumping all the money I have into a race motor so I can blow it up after 4 laps on the little course at Reno, I have a little bit more trouble convincing Jen that's the right path. So, so yeah.
I'm not going to let you get away tonight without showing a little bit of your family here, because we'll be back for more. So you mentioned that, right?
Yeah. So that's Ezra on the left looking not so happy, and then Gid on the right trying to make the same face as Dad. So Ezra's now 2 and Gid's 4, and there's Gid. They're both really into monster trucks and dinosaurs right now. So airplane gas money gets pointed at those purchases. But yeah, there's Gid again. The result being that we really tried to make Wasabi into more of a business rather than a hobby or something we do for fun. I don't need to tell you, you've been through it, but kids are expensive. That phase in your life, there's a lot of other expenses out there. So if I'm going to be flying airplanes, it needs to be a profit center for me. And so building the Wasabi company in order to do to make that profitable has been my focus since walking away from Wasabi. The last time I raced Wasabi was 2014, something like that.
Right,
and so since then, it's just been focused on flight test. So.
Yeah, and flight test is obviously so much of what people watch on with everything that you do on YouTube. It's obviously big. It's your income right now, and the work that you're doing to help so many companies and put all those skills to use. As we are, of course, at the end of our hour, what I would love is there's so much to talk about Wasabi and about flight testing, both for the folks who may be doing experimental, maybe building something like a little thing behind us here.
Hypothetically speaking.
Yeah. Speaking like this thing I want to get out of my house,
Yeah, right.
or finished out of my house, or at the same time, the certified aircraft, and there's so much to talk about. I hope you'll come back and join us again for kind of part 2 of this adventure.
Jeff, I really appreciate you reaching out for this whole thing and letting me yammer at you for the last hour. I feel like I was rambling and not making a whole lot of sense, so appreciate you at least smiling at me while it was happening.
Quite the opposite. I think I speak for everyone who's been on this on our show tonight at SocialFlight Live, that quite the opposite. We want to stay here for like another 3 hours if we had it.
I'd be happy to come back.
It's fascinating. I would love to do that. Let's have another part. Let's talk about so many other things that you do, because they're so critical to people understanding the world of general aviation, the world of experimental aviation, and things that really matter, because we were just talking about it before as a teaser there. Even if anyone's just flying their regular general aviation aircraft out there, you need to think about yourself as a test pilot in an awful lot of situations, including when you pick it up from annual, when you do a modification of some kind, even if it's STC or PMA, doesn't matter. We need to take a different approach here to keep everybody safe.
1,000%, and anything I can do to help, thanks for including me.
Absolutely. Well, Elliot Seguin, thank you so much for joining us tonight on SocialFlight Live. We will make sure that we let everyone know what the date is that you'll be joining us again. And I'd also like to thank all of you for joining us and signing on as you do every week here. Really appreciate it, and everything you do to support the industry that we all love so much. Next week, we have on January 26th at 8 p.m., Ariel Tweedo from Flying Wild, Alaska will be joining us. Get a little bit of a look at the different type of flying and so many of the adventures that we've seen on the Discovery Channel from her as well. On Tuesday, February 2nd, Mike Bush is back. We're going to talk ignition systems and more. And then on the 9th, we're going to talk backcountry flying with the Recreational Aviation Foundation. We just keep changing the subjects, and by the time we get around there, we'll be ready to go back and test flying. So again, thank you so much, Elliot. I really do appreciate it.
Thank you, Jeff. I really appreciate you letting me come along.
Absolutely. For everyone else, I wish you all blue skies.